The can't miss AHR Expo 2025. Find out more at ahrexpo.com. Carrier at carrier.com. Refrigeration Technologies at refridgetech.com. I'm a fan of UEI combustion analyzers, and a big reason I'm a fan is because of their overall low cost of operation, their lifetime cost of operation. Now you can keep your UEI combustion analyzers at their best with the UEI Service Plus guarantee. Book your annual recertification online at ueitest.com/service, and here's what you get. Free shipping both ways, a warranty extension for 1 more year up to 10 years max, and same-day return shipping the day they receive your analyzer. Guaranteed. So don't miss out. Get the full scoop at hvacrschool.com/UEI service. UEI Service Plus. More than a promise, it's your performance guaranteed.
You are listening to HVAC School with Bryan, or did I pronounce that right? Is it HVAC or HVAC? Who cares? These jokers don't pay me enough to get every thing right anyway. Not my problem.
Hey, thanks for the intro, George. George is our slightly grouchy principal of the HVAC school. He's good at his job, but he's a little grumpy, a little beaten down by the years of doing the same job over and over. I'm sure you don't know anything about that. I'm Professor Bryan Orr. Bryan is spelled with a Y. Spell it with a Y, Bryanorr, not with an I, class. And in case you're wondering, yes, I'm going to take the classroom metaphors way, way, way too far till you ask me to stop. I started in the business 16 years ago. I actually graduated high school when I was 16 because I was home educated and a weirdo. Went straight from there into trade school, did that for a year, and then started with my first job when I was 17 years old. Started off as an apprentice working with some super generous, grouchy old-timers who taught me the business, specifically Dave Barefoot. Shout out to Dave. And I quickly moved into a training position where I was training guys who had never done air conditioning before. I say guys. Whenever I say guys, ladies, please just forgive me. It's a habit. I trained both men and women to do air conditioning and helped develop actually a curriculum at the company that I worked for training new people in air conditioning. And they had no business putting me in that position at the time, but it was a great experience for me, and I learned a lot about how to teach people about air conditioning. When I say air conditioning, ventilation, refrigeration, heating, the whole gamut. Now, I will confess, I'm in Florida, so we don't do a lot of gas. You're going to kick my rear end when it comes to anything gas-related. And so I'm going to rely on my northern brethren in order to help bring in some of the northern perspective on these subjects. I certainly don't know everything. I don't know close to everything. Now, the only rule that I have at this podcast is just be kind to the people who are wanting to learn. If you want to rip me, that's totally fine. If I say something stupid, rip me to shreds. That's cool. But when you have people who are putting themselves out there, especially putting themselves out there on a podcast where the whole world can hear, if they start getting too much criticism, it's going to make them gun shy about wanting to confess what they do and don't know, and that's not good for anybody. So this is designed to help people, both experienced and inexperienced technicians. Maybe it's a refresher. Ultimately, we want to make our jobs easier and have a lot of fun doing it. So sit back and relax. I'm going to be talking with Les Broadbent about expansion valves.
So what are we talking about?
We're going to talk about... Okay, all right, so it's Daniel Anderson from the HVAC technician group. Your thing's all crooked there.
This?
Yeah, your pop filter there. You gotta get up and kiss the thing. Otherwise, you're gonna be real quiet, and I'm gonna be real loud.
Maybe I should have like 10 energy drinks.
Well, we got 48 of them over in the corner there.
So I can be a little more vibrant.
Kirkland energy shots over there in the corner of my office. All right, so I'm sitting with Leslie Broadbent. Les Broadbent. Do you want to give just a quick 30-second summary of your experience? Okay, I'm bored. So Les, like most people who have to deal with me, don't really appreciate being recorded that much. But I want to talk about expansion valves, what they do, how they work, and it's a lot more fun if you can talk to somebody else. Now, the first rule of this podcast is that this is not about showing off. So I will say things that are wrong almost assuredly in this conversation.
As I will.
Les will say things that are wrong in this conversation, but it is real and raw. And if people want to make fun of me, that's totally fine. You can email me at any time and make fun of me. That's totally okay. Don't email Les, though. He will probably come to your house and cut you. He does. He does carry a giant. What type of knife is that?
Duckboard knife. Yeah.
No, you don't. You have a giant. You don't. You have a giant cooking knife that you used to carry around.
When?
Back in the day, like you used to carry a cooking knife.
At maybe a small time frame. There was a.
Oh my gosh, this is not going to make for good radio unless you have to be vulnerable here. You have to be vulnerable. You've cut many a man.
Yes,
for making fun of you. Yeah, okay. Good.
Yeah, that's why I'm not in New York anymore. Right. I'm banned from the city.
You probably are. You probably are. Okay, so expansion valve. So an expansion valve. First of all, what's the purpose of an expansion valve? When you think of one, how do you think of an expansion valve?
Metering device, metering the refrigerant flow to regulate superheat into the system.
Okay. So you went ahead and used the word that we're going to get to here pretty quickly, which is superheat, and how superheat relates to an expansion valve, or thermostatic expansion valve, TXV. First off, I guess the thing that ticks me off about TXV is that it's called a TXV instead of a TEV. Like, why the X? Just because it's expansion and they want to be cool? X is always cooler? Why? Why the X?
Probably to shorten it up, probably.
Yeah, it must be.
Just like Christmas, Xmas.
So do you know the predecessors to the TXV, technologically speaking, what came before the TXV back in the good old days?
Most of them were just a piston before they came out with the TXV.
Yeah. And it's funny, I that's another thing. I don't have any idea why they call it a piston, because it's not like, I remember when I first started in the trade, and I had gone to AC school. And in AC school, they didn't call them pistons. They just called them fixed orifices, or accurators, I think was a term that Carrier used to use. Someone used to use that term, accurator. And one of the senior techs, when I walked in, they were having a conversation about something, and they were talking about a piston. And he turns to me and says, "You know what a piston is, right?" And I'm like, "Yeah." And I'm thinking like a piston in a compressor, a piston in a car engine, like
vehicle,
like why do they call this a little hunk of brass that meters the refrigerant? But I mean, for any, because obviously there's going to be a varied audience. Some people who may not be in the trade may not know what a piston is. So
there's a similarity to a piston, though. It moves up and down like the piston would in an engine.
Well, and I think, actually, good point. So that probably is why it's called a piston, because
it shifts back and forth.
Shifts back and forth in a heat pump system, so that way it can equalize. I guess it probably shifts back and forth just even when the system shuts off. It unseats and allows refrigerant to flow freely in the opposite direction.
Once it equalizes, it probably frees up a little bit.
And probably goes back the other way. Yeah, I never actually thought about that. But yeah, that makes sense. So it slides back and forth. I guess I need to look into the etymology of the term piston. But anyway, so a piston or a fixed orifice or the capillary tube was an old form of metering device, which is just a small copper tube or a series of small copper tubes that restrict the flow coming out of the liquid line going into the evaporator coil, right? Or distributor or whatever, wherever it goes directly from the metering device to.
Correct.
But there's actually another device that I messed with at one point in time that is kind of in between the fixed orifice style of metering device and the TXV. Do you know what the name of that is?
No, I do not.
This is making for great radio. Just dead air. That's what everybody wants to hear. It's called the automatic expansion valve, or AEV. And an automatic expansion valve, essentially, just if I remember correctly, and so I'm not reading a book or anything here, so this is a chance that I could say something really stupid, and if I do, correct me, and we'll make a correction in a future episode. But an automatic expansion valve did not have a sensing bulb on it. It was just pressure in, pressure out, and if I remember correctly, it just maintained a set pressure coming out of the valve, so it actually equalized pressure internally, and would make sure that it would have a constant pressure output on the valve instead of a constant superheat, which is what we're going to get into, what a TXV does or a TEV does.
Probably depending on the refrigerant.
Right. So it had to match. Right. So your automatic, well, they were adjustable too. So you could adjust them so you would have a constant inlet pressure on the evaporator. But you know what the problem is with having a constant inlet pressure on an evaporator versus what we do with an expansion valve.
You probably couldn't regulate, superheat or subcool effectively, depending on your climate, your home design, your duct design.
Yeah, load conditions is the term that we would use. So when the evaporator or system overall has varying load, so that could be a case where you have a really hot day outside, and so your head pressure is higher, or you have a dirty air filter, and so your load decreases, or someone sets the temperature cold on the thermostat, and so the actual return air temperature is decreased going over the evaporator coil. The amount of available heat to that evaporator coil is decreased, or the opposite could be true. You could have a really hot day, or let's say you just started up a unit and it's 95 degrees inside the house, really high humidity. That's going to be extremely high heat load. And so when you just output a set pressure, you're not feeding the evaporator coil based on the amount of heat load that's the amount of heat that's being absorbed into the evaporator coil. So then the question becomes, well, I mean, what do you do? What do you do in order to create a circumstance in which you're feeding the evaporator coil the right amount of refrigerant, regardless of varying load conditions that are natural, and then also unnatural ones like, someone overcharging the system, or a filter being dirty, or whatever.
Yeah, certainly a TXV would solve a lot of that issue.
Well, that's the idea. So there's two tubes that go into a TXV. Do you know what those are? I'm explaining this badly. So you have the inlet and outlet, but in addition to the inlet and outlet, there's also two other lines going into the TXV.
The equalizer tube for the sensing bulb. Mm-hmm. Well, the equalizer and the sensing bulb line.
Yes. The equalizer and the sensing bulb, correct. And so the term that's used for that equalizer tube is the external equalizer. And the reason for that is because there were actually TXVs that were internally equalized, and we'll talk about what that is. When I first got into the business, I used to think that somehow that had something to do with equalizing pressures when the system went off. So when I heard equalizer tube, I would think, oh, well, that's where it bypasses, and that's not it at all. On the subject of bypassing the TXV or expansion valve, that happens either with an external check valve or with an internal check valve to the reversing valve. So when we talked about the piston that slides back and forth when the system goes into heat mode, in the case of a heat pump, or when it goes off, in the case of a TXV, you either have to have an external check valve, like a lot of train units have external check valves. We're talking residential equipment here, which is mostly what we're talking about on this podcast. We will talk commercial sometimes. But then some valves, the majority of valves, carrier valves, Lennox valves, are internally have internal check valves. So when the refrigerant starts to flow the opposite direction, it's allowed to flow unimpeded within the valve body. But that has nothing to do, I digress, that has nothing to do with what the external equalizer does. So I'm gonna go away from what we were just talking about a little bit and talk about how we measure superheat. So a lot of technicians, especially new technicians, measure superheat, and so they know how to do the math, but they don't really know what it means. And so this is an opportunity for us to think about what it means a little bit. So when you're measuring superheat, how do you do it? What do you do?
When I measure it and do the calculation, is just the saturation temperature on your suction side with your line temperature, and you just subtract the two differences, and that's your superheat.
Right. So your line temperature is always going to be higher than your suction saturation temperature that you're measuring on your gauge.
Correct.
Could that number be lower?
It shouldn't be if everything's working okay.
Could that number be lower? So can you have a negative superheat?
Yes. In some cases you can.
In what cases?
If you're extremely low on refrigerant.
If you're extremely low on refrigerant, you could have a negative superheat.
Or close to.
Okay.
Or a zero, anyway.
Okay. Well, we're going to back up here a little bit.
Or if you're having issues with your TXV.
Okay.
itself.
So what is superheat? What is it? What does superheat even mean in the first place? So I know this is just everybody who's sitting around this table with us, and you're invisible, you're ghosts, and you're listening to this. Obviously, it's stressful when I'm sitting here and asking these types of questions, and this is a no judgment zone here. This is just exploring the conversation of what all these things are. So if you're listening along thinking, no, that's wrong, that's okay. It's good. I'm glad that you're doing that, but we can't hear you. So of course, Les is not comfortable being interviewed on a podcast, but we're going to work through this. So, okay. So backing up. So superheat, let's talk about what that even means in the first place. We're getting kind of in the weeds here, but this is a good conversation. So superheat, the air around us right now, is it superheated or subcooled?
Superheated.
Okay. And why? How do you know?
I just took a guess.
Well, you made the right guess. Okay, so any vapor, anything that's a vapor, is superheated. Because that's the very meaning of that. That's how it works. But if something is above its saturation meaning the temperature at which it's in a mixed state at a given pressure, obviously the air around us is not currently boiling, right? If it was, we would be dead.
Right. And you can't be subcool.
We would actually be, so when people hear that, actually, so we have Steve who's sitting here listening, and I want to hear what he says about this. So if the air around us was boiling, do you think you would be hot or cold?
If the air around us was boiling, you'd be hot.
Okay, if the air around us was boiling, you'd be hot. And that is what 99.99% of the population would answer to that question. Now, in Steve's defense, Steve is not an air conditioning guy. He's a garage door guy primarily, and he helps out from time to time with different things. So he wouldn't be expected to know that answer. But no, the air boiling, in the case of air, the boiling temperature of air is, I don't know what it is. It's really, really cold. It's like minus, I don't know, 150 degrees, or no, it's way less than that, like minus 200 degrees, something like that. Really, really cold. Somebody will tell me what it is. I'll look it up afterwards. But the boiling temperature of air is extremely cold because air in its regular state is a vapor. So in order for air to boil, it would have to first be a liquid, and then it would have to convert to a vapor. Now, obviously, we're talking about atmospheric pressure because you've changed the pressures. You can change the boiling points. Obviously, that's what we do in air conditioning, right? So when we say boiling is almost, in our language, it's used as a synonym for hot. When you hear boiling, you think hot, right? Because we think of boiling water. That's our experience of the word boiling. But boiling just means something that's changing state from liquid to vapor. Okay? So when we're looking at the saturation temperature on our suction side, what that is that is the temperature at which it will be at that pressure if it is boiling. Okay, it's coming out of the evaporator coil, so obviously it's not going to be condensing, otherwise it'd be a condenser. So the purpose of it was to evaporate or boil in that evaporator coil.
That's where it boils off.
So let's say that our saturation temperature is 40 on our gauge. That means what? Saturation temperature is 40 on our suction gauge. What does that mean?
I'm a loss for words.
You don't know where I'm going with this. 40 degrees saturation means that it's boiling in that evaporator coil at 40 or near 40 degrees. The only reason I say near is because in the evaporator coil, there can be some pressure drop from the point at which it's actually boiling in that evaporator coil to where it's coming down your suction line where you're measuring it. Because obviously we measure our pressures at the condenser, not at the air handler. There's this whole argument about that you should measure pressures at the air handler when you're measuring superheat for TXVs and all this. It's pointless to this conversation because, as you know, most systems don't have ports at the air handler. Most of them are at the condenser. So when you're measuring a 40-degree suction saturation temperature, that's telling you that the refrigerant is boiling at or near 40 degrees in that evaporator coil, right?
Yeah, saturation.
So when it's coming down the suction line and it's reading, let's say, 47 degrees, so that would be a 7-degree superheat, right?
Mm-hmm.
You with me? So that's telling me that it's fully boiled, because if it was still boiling, it would be 40 degrees. 47 degrees means that it's not only fully boiled, but that it's also picked up 7 degrees of sensible heat after the point of it fully boiling off. So after the point of it fully turning into vapor. You hanging with me here?
Mm-hmm.
Okay. What would it mean if it was 38 degrees? If your suction saturation was 40 and the temperature reading was 38, what would that mean, like scientifically speaking?
Well, at 38 from the 40, it'd be a -2.
Correct. -2 superheat. Yeah, there's another word for -2 superheat.
I don't know that word.
Okay, that word is subcool.
Oh.
because yeah. So I'm being a pain in the butt here, but it's easier to do this as a conversation. Okay, so negative 2 degrees superheat would be 2 degrees of subcool. Well, when something is subcooled, we know that it's a liquid. It has to be a liquid. There's no other choice, as long as we know the pressure and we know the temperature. Now, here's the trick to all of you technicians out there who are like, well, I just saw 3 degrees of negative superheat, so what kind of a jackwad are you? Here's the answer. Is jackwad a bad word? Does that make this not a family show? It's a good word? Yeah. Okay, all right. So I can bleep it. I can just say it all the time and then just bleep it. All right, so yes, I am a jackwad, but that has nothing to do with negative superheat. The reason why you would read a negative superheat is not because there is a negative superheat. It's because there's miscalibration in your tools. So it's very easy for a gauge to be a couple PSI off. It's very easy for a thermometer to be a degree or two off. So when you have a gauge and a thermometer that are both off, and they're off in opposite directions, you can easily be 4 degrees off, 4 degrees low in your superheat reading, which would then give you a negative superheat when in actuality you have a 0 superheat. And a 0 superheat is very common. All that means is that you have a mixed liquid vapor mixture in your suction line, which can happen very easily. It just means that it isn't fully boiled off, right? When it's coming down your suction line to your condenser. Now, is that a good thing or a bad thing?
Yeah, usually it's not a good thing.
It's not a good thing.
Usually you're overcharged or something.
Yeah, so you have some kind of sort of a problem.
Then you're going to be slugging your compressor.
Slugging your compressor. You use the S word. So it's not a good thing to have mixed liquid and vapor coming down your suction line. So when you see a 0 superheat, that's what's going on. And when you see a negative superheat, it means that you probably have a 0 superheat, but it means that your thermometer and or your gauge is a little miscalibrated. So calibrate it. It's easy to do. Get another couple thermometers, test it against the one you've got. Get another set of gauges, test it against, make sure it's zeroed out. Easy thing to do. Which, by the way, is one of the single biggest things that technicians do wrong, is not checking their equipment, which is a whole nother podcast for several hours long. So going back to, because we're talking about TXVs here, and I know this is a long story, super boring. We're already at 19 minutes and you're about to fall asleep. But stick with me. What you do in order to measure superheat is you take a pressure that you convert to a saturation, right?
Correct.
And you take a temperature. So a TXV does exactly the same thing. It just does it mechanically, so it's not using a brain and math. It's just using pneumatics. Is that
Pressures.
Pneumatics or is that hydraulics? I always get confused about which is which.
Both.
It's both? They're both. What's the... No. Pneumatics is air.
Air.
So it's hydraulic. So it's using hydraulic pressure. Well, actually, would it be both? Because it's actually a mixed state. Anyway, I'm not sure. Somebody tell me, is this pneumatics or hydraulics? It's one of them. And so it's using one of those in order to do the calculation, not math. The sensing bulb is taking the temperature. Because as you know, that sensing bulb's not connected to the line it's on, right? I mean, connected like the refrigerant doesn't communicate to the sensing bulb.
It's got its own little gas in it.
Yeah, it's got its own charge inside that sensing bulb, and it's a mixed charge. So it's actually at saturation inside that bulb, and it's part liquid, part vapor inside that bulb, and it's sealed so it can't go anywhere. So that's strapped on the line, and then you tap into the line with this external equalizer. Now, what's the purpose of the external equalizer? Getting back to that. It gives you that reading that you would normally take with your suction gauge. It gives that pressure reading. Now, this brings us back to what's the difference between externally equalized and internally equalized. Not that it really matters because you're hardly ever going to see an internally equalized valve, but an internally equalized valve takes the pressure right at the valve and not at the end of the evaporator coil. Well, there can be pretty significant pressure drop from where it comes out of the expansion valve to the end of the coil. So you get a much more accurate superheat reading if you're taking that reading right at the end of the evaporator coil, which is what you're doing with the system. So,
right.
So when you have an old timer who hassles you about the placement of the bulb or whether the bulb is properly insulated, what he's doing is he's helping you get a more accurate reading on that line. So if you have a bulb that's improperly placed or that's not insulated and it's in the airstream, that can affect the way that that bulb is sensing the temperature of that suction line. Just like if you had let's say you took your pocket thermometer and just set it on the suction line, and we're going to try to take a suction reading that way. That wouldn't be a good way. If you wanted to use a pocket thermometer, which I don't suggest, use a proper clamp. But if you were going to, you would take foam tape or Armaflex, or Armaflex is the wrong word. That's
cork
a trade
tape.
word. No, cork tape just makes a mess. I freaking hate cork tape. This is a whole nother subject.
It is sticky.
It's like, and so anyway. So one of your guys, because Les is the add-on replacement manager, they use cork tape to seal around where my line set goes through my platform at my new house that I just built. I mean, granted, if I wanted it right, I could have done it myself. But it's just gross. Like, this stuff is just, it leaves black goo just everywhere. And, like, my kids go and touch it. And I think we're a little off topic here.
It's okay, though.
Okay, so line insulation.
Kids can play with it.
So you put line insulation around it with your thermometer, and then that would give you a more accurate reading of the line, not being affected by the temperature of the air around it, right? Correct. And so that's why it's so important to properly insulate a sensing bulb, because the sensing bulb is doing exactly what you would do with your clamp-on thermometer at the condenser. Only it's doing a better job because it's taking the pressure and temperature reading, not outside where, you know, the suction lines had a chance to have kinks in it and have uninsulated sections in a chase where it picks up temperature or whatever. It's actually reading an accurate temperature and pressure right at the outlet of that evaporator, which gets to the point of what a TXV does and what its job is. Its job is to maintain a constant superheat. And I don't know if this is true or not, but I think someone told me this at some point. But when they first came out, they would call them a constant superheat valve. And then they started calling them a TXV, which I like the name constant superheat valve a lot better.
CSVs,
Yeah, constant superheat. Let's start a revolution of calling them CSVs.
Let's do it.
Yeah, let's do it. So it started here.
From here on out, every meeting, it's a CSV.
I would take credit for it, but given that I'm a good leader, you're the first one to utter the word CSV. So if it catches on in the industry, it's Les Broadbent who's the source of the CSV. Anyway, so constant superheat valve. So that's its job. As long as you give that valve a full line of liquid, which means subcooled liquid, then its job is to take that liquid and convert it into a properly loaded coil. And a properly loaded coil means whatever the manufacturer setting of superheat is on the outlet. Now, you know, there's a lot of debate. What should the outlet be? What's your experience of the superheat of it on a TXV system? Like, what do you normally see, Les?
Most systems will have anywhere between 6 to 15 degrees superheat.
Yeah.
Depending on how long your line set is, where the air handler's placed, condenser's placed. Sometimes that all plays a role.
Yeah.
In what you're getting.
That was actually a pretty good answer. That's probably a better answer than I would have given, because we're reading the superheat at the condenser. Sometimes it will be higher, but in general, the manufacturers are going to have, you know, maybe a 5 to 10 degree, maybe 12 degree superheat at the outlet of the evaporator. And so based on, and if I just said this wrong, that's fine. Throw me under the bus, you know, whatever. Just tell me if I'm giving you wrong numbers here. But that was my experience. It's been a while since I've run service myself. Let's be real honest. But back in my day when I was a lad, I used to see that sort of thing all the time. Anyway, so if the manufacturer is setting a 5 to 12 degree superheat at the outlet of the evaporator, then you could have, you know, maybe anywhere from 5 to 12, maybe 15, 16 degrees superheat at the outside unit where we measure superheat most often. This gets to the tricky part of diagnosing TXV problems. Let's say you walk up to a system, and let's say it's an R22 system, only because I'm much easier spitting out R22 pressures than 410A. It's funny because I was in the group, in the HVAC technicians group on Facebook, and they were just spitting out saturations, and I'm trying to convert saturations to pressures in my mind, because that's just how I think of it. Like that's how I came up through the trade.
Which I cannot do.
Oh, okay. Well, R22 I can do, but 410A I just don't. I mean, I know how to read a gauge, obviously, but I just don't have that in my head as easily. Anyway, so let's say you have a system, an R22 system, and you're measuring the superheat outside, and you're measuring a 12 degree superheat. Well, let's make it a 10 degree superheat to be generous on the system, okay? And you're running a 55 psi suction, okay, which is like what is a 55 psi? So that's like 29. I'm not looking at a PT chart here, but it's like 29 degrees, something. It's below freezing. It's bad.
Sounds good. It's close to freezing.
It's not good. And let's say that it's 85 degrees outside and 80 degrees inside the house, and you have a 14 degree split, and your subcool is 12. What are you thinking?
Could be possibly low on charge, dirty filter. I would say it's low on charge given the room temperature inside the home, and having a 55 suction. Usually they're close in relation to the nominal temperatures.
Okay, so you're going to add some charge to it.
Maybe a little just to see what would happen.
Okay, how much are you going to put in?
Maybe a half a pound to see if something happens.
You know how much that stuff costs? Oh my gosh. We're not going to get into prices here, but that stuff is expensive. Oh man. You probably didn't quote the customer.
Oh, I always quote the customer.
Oh, so you quoted the customer for something they didn't need now. What are you going to do, unquote them?
No, I put it in there somewhere.
Because your diagnosis is wrong. Sorry, I just peaked them. I just blew up my whatever it's called, recorder here. I'm so passionate, I don't even know what my equipment's called. No, so you know that it's not low on charge because your subcool is good, right? Your subcool is, what did I say? What did I say, Steve?
12.
Didn't you said superheat was 12, didn't you?
I said the superheat was 12 and then I changed it to 10, but I said the subcool was 12, I think. 10 and 12. So you know the system's not low. Your subcool is what it should be. Now, okay, is it possible that you could have a kink in the liquid line or something in between from where you're reading it at the condenser? Yeah, I mean, that's possible. But generally speaking, what you would do next if you wanted to confirm is you'd take a temperature on the liquid line outside, you take it on the inside to make sure that there's no big difference there. But if you know that you are giving that expansion valve a full line of liquid and it's coming out and it's giving you the proper superheat, well, what you know is that evaporator coil has a low load on it. And low load is in the biz, a lot of times guys would say, well, it's got low airflow. Well, it's not necessarily true. It just has low load. So it's not getting the heat that it needs. That evaporator coil is not getting the heat that it needs. And that can happen. Like if you remember that one crazy furnace that we had years ago where one of the guys installed the case coil on the wrong side of the furnace. Do you remember that?
Yes, I do.
Well, that's an example where it had the proper airflow, but the coil wasn't getting proper load because while the airflow was going through the unit, the airflow was not properly going over the coil, so the coil wasn't getting the amount of heat it needed, right? Needed, when we say needed, it wasn't getting the proper heat, the amount of heat that it needed in order to keep the suction pressure above freezing on a TXV system. Because what the constant superheat valve is doing is it's saying, I don't have enough heat here in order to boil off all this refrigerant. So I'm going to keep slamming down. I'm going to keep decreasing the orifice size on this valve until I balance out the load. And so it does its job. It says, I've balanced out. I've created the superheat at the outlet that I'm supposed to. And so I'm all hunky-dory. In the meantime, the unit's freezing to a ball of ice because that expansion valve doesn't have anything in it. It has no brain to know that the suction pressure is going down so low that it's causing the unit to freeze
up.
Right? And so in engineering, when air conditioning systems are designed, they're designed to be in certain load conditions. And when you run them when it's way too cold outside, when you run them when it's way too cold inside, when you run them with not the right amount of airflow, when you run them with a case coil not installed properly, when you run them with a air filter that's all clogged up, improperly designed duct system, all these things that you can reduce the load on the coil, that expansion valve is going, whoa, hey, I'm slamming down. So the most common, and you didn't do the most common misdiagnosis on an expansion valve, which is to replace the valve. You see low suction, you got a full line of liquid, and so you replace the valve.
Yeah, I wouldn't jump right to the
so you would have put in
CSV.
Yeah,
I wouldn't jump to that.
Yeah, I see what you did there. CSV. Yeah, are you actually? I want to see if you actually continue to use that. I think
I'm gonna. I think I'm gonna.
Pretty sweet. Yeah. So the constant superheat valve is doing its job. The CSV. So you would probably put a half pound of refrigerant in, and you would have noticed that your subcool is coming up, and your head pressure is coming up, but your suction's not coming up. And so then you would have said, "Oh, okay, well, let's see what else." And then, of course, you wouldn't have charged that customer for that half pound.
Probably not.
Yeah, because I know you're a good guy, and you would never do that kind of a thing. I'm not. I'm acting like I'm sarcastic. Les is a good guy, and he never would do that kind of a thing. But it's a common thing. So those are the two common things that you would do. You would either start jack and charge in the system in order to try to get your suction up, because that's what guys do. You see low suction, you think, let's get some charge in that. And on a orifice system, that may be a reasonable thing to do. But in this particular case, because you have that constant superheat valve, and you know that you have the subcool that you need, the valve is just doing its job, and it's a low load condition. Now, you know what? I did screw up, though, because for some reason I told you that it had a low split, and that's wrong. So it should have had
a high split.
Yeah, everyone's screaming at me. Okay, so back in time, not a 14-degree split, a 24-degree split. Anyway, so
yeah, between the pressures and the split, that's why I would jump to the half pound.
Oh, okay. So now you can justify it. I like it. So Les didn't screw up. I screwed up, people. Anyway, so. The expansion valve's job is to maintain a constant superheat. Now, what are some things that can go wrong with an expansion valve? What are some things that you've seen, like when an expansion valve is failed?
Either slam closed or slam, fully open, and they're just not regulating properly.
Right.
So it's letting in too much or not enough.
Right. Okay, so what do you see most often, though? Do you normally see them slam shut or too far open? What's most
Usually
common?
slam closed.
Usually
So,
slam
yeah.
closed. Okay. And there's a reason for that. The reason is that the actual bulb, the sensing bulb, is responsible for the opening force of the valve. So as the sensing bulb gets warmer, the valve opens more. That's why you have a lot of guys who do all sorts of crazy things with bulbs, anything from taking them off and warming them in their hand to running a torch on them, because when the bulb gets warmer, it applies more opening force on the valve. Okay? So
Which I did the other day, actually.
what did you do? Don't say it if it's something awful.
Nope, I took the bulb off and put it in a cup of ice water and see if my pressures would change.
Go down in that case.
Yeah.
Okay, yeah.
And then I heated it back up in the palm of my hand, and that changed, so I knew the TXV was doing its job.
Well, okay, that's a common thing that the guys will say. Oh, no, hey, no problem, just your phone's ringing really loud. You need to get that?
Nope.
You sure? Who is it?
My father-in-law.
No.
So it's probably my mother-in-law.
Is that a bad sign?
No, I wouldn't think so.
Okay, I hope not.
I don't really pay much attention to them.
Oh, wow. I hope they don't listen to the podcast, or any of your family for that matter, your wife or anybody. Anyway, what were we talking about? Oh, we're talking about, so common misconception is that when you do the, does it shut, does it open test, that if it does, that there's nothing wrong with it. Well,
For the most part.
for the most part, that's true. It means that the valve is acting, and it means that the bulb is acting upon the valve. It doesn't mean that the valve doesn't have something else wrong with it. I mean, it could have something clogging the inside of it. And another thing to mention is that a lot of valves do have screens, inlet screens, and that can give you kind of false readings thinking that it's the valve when it's really just a plugged screen. So that's something you'd have to have enough sense to know. And generally speaking, what I suggest is doing a freeze test and seeing the point at which it starts to actually get cold and that kind of thing, which that's not really what we're talking about here. But the common test would be exactly what you said to see if it's acting. And the reason why they more often than not fail shut is because the bulb is the opening force. And one of the most common failures of an expansion valve is the bulb losing its charge, which it can happen because it's been handled roughly in the tube cracks. It can happen a lot of different reasons, but essentially the charge is leaving the bulb. And when the charge leaves the bulb, the TXV has no opening force.
Or it gets overheated from...
Yeah. When it gets overheated, usually what happens is that, you're causing too much pressure to build up, or you're melting something, something's actually melted and broke. And that's when you do the, warm it up in your hand, put it in the ice water test. That's when you're not going to see any change because there's no charge in the bulb for there to be a change. But there are other issues that can happen. And so when you have when you have a system where the expansion valve is opening too far, that can also happen. And you would see that result by having a high suction pressure and a low superheat, a low or zero superheat, which is often something that I think techs have a harder time catching because we're programmed to look for systems that have low suction pressure. That's what we're just trained to look for low suction pressure. So when you see a system that has a little higher suction pressure and has low superheat, we maybe won't catch that. But it is something to at least watch for. And the reason why that can happen is because the external equalizer is the closing force of the valve. And a lot of times when guys will replace guys and ladies, because of course the lady technicians out there, I don't want to ostracize you, ladies and gentlemen, when you replace an expansion valve, you'll a lot of times make a new port for the external equalizer. And if you get solder inside of that tube, that can affect the opening force, the closing force of the valve. So if you block off, if you have all opening force from the sensing bulb opens it. Correct. And you don't have the closing force from the equalizer, then that offsets the balance of the valve, and that causes it to be too far open. That can happen. It's not very often, but it's usually after a valve's been overheated or somebody didn't do a good job of tying in the external equalizer to the valve. In addition to that, you also have a spring that affects the setting of the valve. And in some valves, you have an adjustable spring. And so if you take, in some valves, you take the bottom nut off the valve, you can actually adjust the superheat setting of the valve. The more that you turn that screw on the bottom clockwise, the more the valve opens and therefore lower superheat. The more you turn it counterclockwise, the more it closes, and therefore higher superheat.
Yeah, most commercial applications.
That's where you'll see adjustments on an expansion valve. But generally speaking, that's not something that you do because they're set from the factory to be what they are. And if there's something wrong inside the valve, where it's either giving you too high or too low superheat, then the valve is failed. But the trick with that is that, of course, the valve has to have a full line of liquid. So if it's got clogged screens, clogged filters, anything that's causing it not to get a full line of liquid, it can't do its job. And you have to be checking superheat. So the moral of the story that I would give is that check superheat all the time, even on a TXV system. So when guys say, why would I check superheat? It's a TXV system. I set the charge by subcool. Correct. You set the charge based on the manufacturer's recommendations, no matter what they are. And in the case of a TXV system, that's most often subcool.
But it regulates your superheat.
Correct. And so if you're not measuring your superheat, you're not checking on your valve the way you're supposed to be. So you don't set your charge by your superheat in the same way that you don't set your charge by your air temperature split, right? Or delta T, whatever you people want to call it, evaporator, air temperature split, dry bulb, evaporator, return to supply, delta split T. You don't set your charge by that. You take it in order to see the overall health of the system, including evaporator coil loading, airflow, a lot of things. You take your superheat in order to check the health of your expansion valve and to make sure that you don't have, possibly other restrictions that could be causing the system not to have the superheat that it should have. Because superheat is one of the single most indicative, I used a fancy word there. Did you like that? Indicative. Yeah. One of the single best indicators of how you're doing in the evaporator coil, whether or not you're feeding that evaporator coil with the proper amount of boiling, evaporating liquid refrigerant, which is ultimately what results in the house having heat removed out of it. And that's what we want. House or office, of course.
Correct.
So how would you care to summarize this conversation, this wide-ranging conversation that we've just had, as it's gone twice as long as I told you it would?
Well, to summarize everything that we discussed on the CSVs, aka TXV, we're going to start using that terminology around here. Then the CSVs regulate the superheat, but is monitored by subcool. Basically, just making sure your pressures and temperatures are working effectively together to get the right metering going on in your refrigerant circuit.
Okay. That was a little bit of fancy talk, so let me see if I can break it down. It's a constant superheat valve. Its job is to make sure that the evaporator coil is fed with the proper amount of boiling refrigerant. It does it by using the external equalizer and the sensing bulb in the same way that you use your thermometer and your gauges in order to measure superheat outside. That's its job. If you're giving it a full line of liquid, then its job is to maintain a good solid, let's say 5 to 12 degree superheat at the outlet of that evaporator coil. Okay, there are other factors that can mitigate that, and so you have to do some tests in order to make sure that you're getting your full line of liquid and all that. But if you've got a system that's running low suction and that TXV is giving you the proper superheat, then the TXV is not bad. And Correct. So stop misdiagnosing TXVs, people,
because we hate changing them out.
Well, and I also wouldn't mind getting a sponsorship from some manufacturers, and they don't want you to keep warranty replacing TXVs when you actually have bad airflow or improper. I shouldn't say bad, incorrect heat load going to your evaporator coil.
No, they're not bad to change out. They're quite easy. So
yeah, well, the manufacturers don't like. You don't mind, yeah, you don't mind. All right, I think that's all for today, ladies and gentlemen.
Thank you so much.
There's no ladies sitting here, but there's some ghosts of some listener ladies who are listening, and your wife who keeps calling and texting while we're
better check that out. Yeah. Make sure it's not an emergency.
Okay. All right. Thank you, Les.
Thank you.